Hey guys, so today we're going to be talking about probability distributions. Okay, so probability theory was initially developed in 1654 with the series of letters between two French mathematicians, Blaise Pascal and Pierre de Fermat. And that's because they just wanted to, determine fairness of games. And it's still used in casinos with customers and, settling interest rates and such things like that. But you can use it for rolling a die, flipping a coin, drawing a card, spinning a Game Boy spinners, and any type of random chance thing. So probabilities are always expressed as a number between 0 and 1, meaning it's going to be inclusive to those numbers. Okay, so the probability that an event that is certain to happen, that it will happen 100% of the time, is going to be 1. Okay, but while the probability of an impossible event, meaning it will never ever happen in your lifetime or my lifetime or anybody's lifetime, is going to be 0. So for example, if we're looking at a rolling a single die, all the possible outcomes known as the sample space is going to be 1, 2, 3, 4, 5, and 6. Now each of those numbers represents the side of the die that it will land on. Okay, and the probability of each of those events occurring is 1 out of 6 times, because there are 6 total possibilities, and you can only get one side when you throw it. Okay, so this is the probability distribution of a die is below. So if we roll 1, we will get it 1 out of 6 times. 2 is going to again be 1 out of 6. 3 is going to be 1 out of 6. 4 is 1 out of 6. 5 is 1 out of 6. So no matter what we are trying to roll, we are going to get a probability of 1 out of 6 of getting any number on there. Okay, so a probability distribution is a table or an equation that links each outcome of a statistical experiment with this probability of occurrence. So this table right here that we have is a probability distribution. It shows each and every single outcome's probability. So the sum of all the events in this sample space is always going to be 1. So if I were to add up all these 1/6, it was going to be 1. I can even count it. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 is going to be 6 out of 6, and 6 out of 6 is 1. Okay? Alright, so moving on. So this is considered a discrete probability distribution because we can count every single outcome. We can only roll these 6 values on a die. There's no way we can get 1.4, 7.36. I mean, that's not even in our sample space. We can't even get 2.63498. We can't get any decimal value. So there are gaps between the values in the sample space. That's how we know it's discrete. Now, when there are no gaps in our sample space, we have a continuous probability, meaning we could get those really small numbers with the very small amount of space in between them, but there is no gap. We can always find a number in between another number. So continuous distributions are created for variables that are measured rather than counted. So things that are like weight, time, height are continuous variables. So let's move on to calculating our probabilities. Now when we're calculating a probability of something, this something is called an event, and we went over this with the fundamental counting principle and permutations. So the probability of an event that is going to happen is written as the probability of this event. So P of E. Okay? P stands for probability, E stands for event. The probability of rolling a 3 on a die would be written as the probability of a 3. Does that make sense? So probability of a 3. So now let's look at the next one. So what is the probability of rolling at least a 4? So keyword, at least. So that means we need to do a 4 or anything above. So we can write that as probability of x, meaning what number we roll, is greater than or equal to 4. Because it can be 4, but it's also going to be anything above 4. So this can also mean probability of 4, 5, and 6. And we know those probabilities individually. So probability of 4, probability of 5, and probability of 6, well, it's like we're going to have 1 over 6 plus 1 over 6 plus 1 over 6, which is 3/6, but that reduces to 1/2. So we have a 1/2 probability of rolling a 4, 5, or 6. So to calculate a probability, you count the number of ways it can happen and divide it by the total number of outcomes. So in our case, number of ways it can happen, the number of ways we can roll 1 is 1 time. But the number of outcomes we have is 6. So, and this is going to be defined more specifically depending upon the type of probability. And we'll get into that in a second. But in general, the probability event is going to be the number of ways it can happen over the number of outcomes. Okay? So moving on. And that's a good formula for you to have, so I'll pause for a second there. Right. So there are two types of probability that we're going to be talking about. There is theoretical. So what is expected to happen based on math? So what is expected to happen? So this is kind of like our rolling dice. So this is the number of favorable outcomes over the total of all possible outcomes. Okay, so let's look at this first example. So we have a bag that contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. A marble is drawn at random from the bag. So the first thing that I want to identify is my sample space, meaning how many total marbles do I have in the bag? And what I'm going to do is I'm going to add the 4 plus the 6 plus the 3. So the blue, green, and yellow. So 4 plus 6 plus 3 is going to give us a grand total of 13. So that's how many total marbles we have. Now let's look at our first question. So we have the probability of drawing a green marble. So the probability of drawing a green marble is the number of favorable outcomes, which is the 6 green marbles, over our sample space, which is the 13. And that's my probability. Okay? So the probability of drawing a yellow marble. So again, how many yellow marbles do we have? We have 3 yellow marbles, and then it's going to be over my sample space. So 13. So we have 3 over 13. Okay? So then we have, what is the probability of drawing a green or a yellow marble? And that is a very important or. Make sure you understand that or means you're going to add them. So a green marble, as we defined, was 6/13, and then our yellow marble probability was 3/13. We're going to add those two together, so our probability of finding green or yellow out of the bag is going to be 9/13. Okay? So now we have our other type of probability. This is experimental probability, and it's found by repeating the experiment and observing outcomes. So this would be given information for us. So number of times, and this will be, the probability is found by the number of times the event occurs over the total number of trials. Okay, so let's look at our first question. So we have calculate the following probabilities. So we have the probability a driver is a mobile phone user. So let's look at this. So the driver is a mobile user. So driver using mobile phone. So we're going to highlight this entire column, and that will be our drivers using mobile phones. Now, we're going to take the total number of mobile users, which was 325, and we're going to put it over the total number of drivers in general. So that's going to be 755, and that is my probability. Okay? So now let's look at my next one. So a driver that had no accidents in the last year. So did not have an accident in the last year. We had 685. And that's going to be over the total amount of drivers. So 755. And that's my probability. And if we were to find the decimal of this, it's going to be 0.097. And for this one, it's 0.430. Then our last one, a driver using a mobile phone and had no accident in the last year. So there's two things that we need to see. So a driver using a mobile phone, so this row right here, and they had no accident in the last year. So we kind of see where are my two highlighters intersect, and they only intersect at 280. So we have 280 is the number of times that our event occurs, and then we're going to have it over the total number of trials, which again is my 755. And that is my probability, and as a decimal, that is 0.371. Alright, so that is probability distribution. Make sure you understand those key terms, and I'll see you next time.